Welcome back. Now that we've gotten into the weeds of how to optimize our code, let's talk specifically about React. How can we optimize our code in React, such as our RoboFriends app? Well, for any React developer, the first thing you want to check out is a feature that has come ever since React 15.4.0, and that is our performance tool. All we need to do is, in our local host, give the query string parameter of React perf, React_perf. From here, if you hit enter, nothing happens. But if you open your developer tools and go to performance, we can now do something really interesting. I'm going to hit record, type a few things in the search box, and then hit stop. And then we're going to analyze them, or analyze the performance of our app. Let's hit record and type things really fast and change stuff and stop. Just 7 seconds. Now, by using this React_perf, we can now see our components and what they're doing in the performance tab. Now, I know this is overwhelming, so let's try and go through it nice and easy. We see that we have our app that is rendering and being filtered. And we want to take a look here at the CPU section. We see that there's some nice yellow bars over here. That means some JavaScript happening. So I'm going to highlight it by just clicking and then unclicking. And you see in the user timing section, well, here in the user timing section, if I scroll in, look at that. By using React_perf, now the Chrome Developer Tools recognizes React components. You can see the React logo here, and shows us what kind of work it's doing. We see that we have the React render tree just at this moment in time. We have the connected app. Remember, we're using Redux. We have the app as our main container component. And underneath it, we see that we have card list, error boundary, and scroll components. And underneath that, we see our card components. Very cool. And we actually see here what they're doing. In these square brackets, we see that it's updating. So because I've probably typed something here, you can see, yep, I've been typing something in this section. These components are updating. And each color bar shows time that a component is doing work. Since JavaScript is single-threaded, whenever a component is mounting or rendering or updating, it's hogging the main thread, remember, the main worker of the browser, and preventing other code from running. These bracketed quotes that say update, and sometimes they'll say render and mounting, they describe what part of the component lifecycle is taking place. And the timeline breaks down each step. You can see fine-grained timing on the methods that you're using. Our app is fairly small, so you don't see too many jumps here. But as you get more and more components, you can imagine how this is going to go deeper and deeper and deeper into the render tree. I like to call this the reverse Christmas tree. And the bigger the reverse Christmas tree is, the more and more components needs to render. Because remember, the way React works is if something updates in the app, it will update and pass down those props to all the components below it. And all those components, which are functions, need to run and re-render. So you want to avoid something where it's really deep. They look like just pyramids of doom, just massive pyramids, or reverse Christmas trees. Now, it's typical to have fairly deep component trees in React, but if you're optimizing a component that is mounted frequently, it can help to reduce the number of wrapper components, such as the connect component, since each adds a small performance and memory penalty. Now, one thing to keep in mind here is that when you run this, it's running on the development version of React, which is a lot slower because you get extra tooling. Plus, even running this React perf slows down your app. So it's not the exact same as your production. Production will most likely be faster, but it is a good indicator of what your app is doing, and you can test out to see, where are my bottlenecks? Now, looking at this, we might have realized something. How can we help this process with Redux? Well, by using Redux, we can be smart about what components update. Because if this top level component updates, it's going to render all its children or re-render all its children. But if we have Redux, and instead of using this root component to update the state, we can just directly connect a lower component. Remember, by using connect, we can connect to the state so that we can now just connect the component here, and only these two below it will update, versus if you had the top level component connected, which will re-render a lot more components. So that's the strategy there. Do you want to have just one top level container component or just a few components at the top that are connected to Redux? Or to avoid passing down props in really deep nested trees, do you want to use connect closer to the leaf nodes? And that is an architectural decision that you and your team make based on these pros and cons. Finally, I also wanted to show you the React developer tools. This is a Chrome plugin that you can get. You just click on Add to Chrome and you'll have it. And it's very, very useful. If I go over here to the React tab, you see that it shows my app. I have my props and store. I have my provider, my connected app, my app, and then I see my search box, scroll, and then finally all my children component. The cool thing about this is that it shows you what props you have, what children you have, all these things. And as we change things, you can actually notice the changes. But for performance, the React Developer Tools is really, really nice when you click on this, Highlight Updates. And what will happen is anytime your app changes or a component is re-rendered, it's going to highlight it. Let's check it out. I'm going to start typing, and look at that. It shows what is being re-rendered, which is pretty much all of our app. And watch this, as I type faster, do you see that? I went really, really aggressive with the typing there. But you see how the colors change? Well, the color represents how often things are being re-rendered. The faster they're being rendered, the closer they are to the color red. So think of the hot colors. And the slower they are, the closer they are to blue. Now, this is helpful for detecting unnecessary render cycle. For example, as I type here, I see that my header is being updated. But why? I mean, it's just the same the entire time. Why would I need to re-render this? That's a function that's running that's kind of unnecessary. And when we look back at our code in the app.js, we see that, well, it makes sense. Because every time I do the onSearch event, I have to dispatch an action and it updates the search field. So this app.js component gets re-rendered because there's a change in the Redux store. And because the header is part of this, it's going to re-render as well. So these are the kind of things you want to start noticing. Now, keep in mind that seeing yellow or red when you're highlighting or when components are re-rendering isn't necessarily a bad thing. It's going to be expected when you're doing things like sliders or scrolling or any UI elements that triggers frequent updates. So you can't completely avoid it. But if you're just clicking a button and you all of a sudden see a red, that means there's something going on that you want to fix. So the tool here, the highlight updates, is mainly used to see what's being updated unnecessarily. And as an app developer, you want to have a general idea of how your React app is being rendered. Because remember, we want to avoid unnecessary DOM manipulations because we know by now that that really hinders our performance. So in the next video, I'm going to show you how we can avoid some of these unnecessary re-renders. I'll see you in the next one. Bye-bye.